Hello, my name is Julia and this is Space Daily News channel. The European Space Agency Interplanetary Station JUICE was launched on April 14 on an Ariane 5 rocket from the European spaceport in French Guiana to begin its 8-year journey to Jupiter, where it will study in detail the gas giant's three large moons, Ganymede, Callisto and Europa. The launch was originally scheduled for April 13, but it was postponed by 1 day because of weather conditions. Interestingly, the JUICE mission has a very tight launch schedule, as it must be launched at a strictly defined time in a day to the nearest 1 second. Such precision is necessary to ensure that the spacecraft gets its right acceleration at the right time. On its way to Jupiter, JUICE will orbit Venus, the Earth and the Moon to increase its speed and correct its trajectory. And to do this, all the planets must be in right position relative to each other. The launch of the JUICE mission involved several stages. Less than half an hour after liftoff, the 6,200 kg JUICE vehicle separated from the upper stage of the Ariane 5 launch vehicle. Then, about 9 minutes after separation, the spacecraft communicated with the ground station. Then JUICE began deploying its cross-shaped solar panels. The JUICE solar panels consists of 10 pods with sizes 2.5 by 3.5 meters, 5 on each side, with a total area of 85 square meters. They were stacked inside the head fairing of the Ariane 5 rocket during launch. The deployment of these panels is a critical step for the success of the mission. 100 minutes after launch, the mission team received confirmation that the solar panels have been successfully deployed. Now, over the next 7 days, the JUICE spacecraft will have to deploy a 2.5-meter diameter antenna, as well as a magnetometer that will collect data on the magnetic field of Jupiter and its Galilean moons. Then, for 2 months, scientists will test JUICE spacecraft and its 10 scientific instruments: a UV spectrometer that will produce images of the polar lights of Jupiter and Ganymede, a submillimeter spectrometer to study Jupiter's atmosphere and the exospheres of its moons, as well as the thermophysical properties of the surfaces of the gas giant's moons, a laser altimeter to study the tidal deformation of Ganymede and its surface topography, several cameras to study global, regional and local features of the moons, as well as to map the cloud cover of Jupiter, magnetometer to characterize the magnetic field of Jupiter and its interaction with the magnetic field of Ganymede, spectrometer to obtain images of the satellites and Jupiter, as well as to determine the surface composition of the icy moons, several sensors to characterize the plasma environment of Jupiter's system, also an ice-penetrating radar to study the subsurface structure of the ice moons at depths of up to 9 kilometers, instrument to study the radio emission of Jupiter, and a set of instruments to study the gravitational fields of Jupiter's moons, as well as to study the structure of Jupiter's ionosphere. The journey to Jupiter is expected to take 7.5 years, and the spacecraft will reach the gas giant in December 2031. The JUICE will allow scientists to learn more about Jupiter's moons as potential sites for life in the past or perhaps even in the present. JUICE will answer several key questions, such as what are Jupiter's ocean worlds like, and why is Ganymede so unique? Could there be or ever have been life in the Jupiter system? How has Jupiter's complex environment shaped its moons? What is a typical gas giant planet like? How did it form and does it work? Ganymede, the largest and most massive moon in the solar system, will be studied in particular and unprecedented detail due to the role it plays within the system of Jupiter's large icy moons and its unique interactions with the Jovian environment. JUICE will be the first spacecraft to ever orbit a moon in the outer solar system. Space Daily News, like, share and subscribe.